5:15. Welcome, everybody. Welcome to those online. We are here to answer your questions about ASP.NET. I think it's the future of ASP.NET is the title. And Blazor, which is part of ASP.NET, but we like saying the word Blazor, so we always call it out separately.
Part of the family.
Right, so we do have like some early questions. Some folks got here early online and posted questions. Do we want to go to those ones first?
Intros first. Who are you?
Oh, okay. Yeah, I'm Damian. I work on the .NET team.
I'm David.
Can they hear you?
I'm David.
There we go.
I'm a distinguished person on the ASP.NET team.
I'm Daniel Roth. I'm a product manager on the ASP.NET team.
I'm Jeremy Likness, and I'm also a product manager on the ASP.NET team.
Excellent.
Wait, hold on. You're all PMs. I'm here.
Except you.
Okay, cool.
We brought you to give
Balance. I'm balanced. I'm the balance. Oh.
So we all promise product, and then you engineer it.
I tell the truth. Okay.
You and all the other engineers. Okay. So we do have one. So I think, Dan, I think the first question is for you, which was how does Blazor, I don't know if this is a asked in good faith, but it says, how is Blazor different from ASP.NET 1.1 inline server code inside my HTML?
Can we just take a moment and just recognize what an awesome web framework ASP.NET Web Forms was?
Yes, thank you.
Just take a moment. Freaking awesome. And you know, I've often tell the Blazor team that if we can achieve the same level of success as ASP.NET Web Forms, then we have made it. We have done it. Yeah, I mean, Web Forms is great. When was it that we started ASP.NET Core? Now it was like 5 years.
2014.
8 years ago.
10 years ago.
Yeah. So we made a call and said, you know, it's time to do something new. It's time to take what was then .NET Framework, was part of Windows, closed source. Time to take .NET and make it cross-platform, open source, and it's time to take a fresh look at what it means to build a web app with .NET. And that's where the whole ASP.NET Core effort came from. So it's important to recognize that we rebuilt the web stack from the ground up, new middleware pipeline. We had a bunch of goals when doing that, and you probably could speak better to that to me, like performance, composability. You know, if you wanted to get down to the bare wire, you could. You pay for play. If you wanted to add things to the stack, then you add them in, as opposed to sort of the kitchen sink model. So that was the context for, you know, why did we redo ASP.NET really with the new modern .NET platform. And if you've been following along on the .NET blog, we've been publishing these developer user stories about, a lot of them are Microsoft teams that are taking older .NET Framework code bases built with ASP.NET and are modernizing them now onto the new modern .NET platform, ASP.NET Core, and achieving just phenomenal performance and efficiency increases, like huge cost savings for those projects. You know, these are some of the largest services I assume on the planet. You know, hundreds of billions of requests per day for a lot of these
Hundreds
services.
of billions of requests per day.
Hundreds of trillion, I don't know.
Some of them, like, you could even maybe get to billions of users, some of these services.
Yeah. So big investment there. And that, I think, was long-term investment. I think it's paid off. We did decide not to bring web forms forward onto the ASP.NET Core stack, although the community then went and said, you know what, we're going to do it anyway. I think it's Rubicon is a company that went ahead and has done a port of web forms to ASP.NET Core with the limitations that are involved with doing that. But if that's something you're interested, then by all means, check that out. We just felt there was too many breaking changes with the old stack that made it hard to bring that framework forward as it was. And so we started a new path. We did bring MVC forward. We felt that was a modern pattern, and we wanted to have that available. Blazor was built to fill in that gap that we had then with .NET, where you couldn't do anything on the client. You couldn't do anything in the browser unless you wanted to go to a completely different developer ecosystem, write in JavaScript, completely different tool chain, different skill set. Blazor was built to fill that hole and say, no, let's provide a way where you can build the entire web application using C#, using .NET, using the tools that you know. And now in .NET 8, we are expanding that vision where you can take your Blazor components, that framework, that component model, and extend it from the client to the server. Be able to build the entire front end part of your web application using .NET and C#. So that's how we got to where we're at. Is that different? I think if you look at the frameworks, you'll look under the hood that it's completely different at the ASP.NET Core layer and below. Yes, both have components and controls, and they're both event driven. And I think a lot of web forms devs that come to ASP.NET Core and Blazor, like they like that. Like, wow, this is something that feels familiar. But it is fundamentally different in terms of the technology about what it's doing, like the ability to run .NET code directly in a browser on WebAssembly. That's all very, very new and modern.
All right. Do we have an in-room question? Mike Mann.
Let's say I wanted to contribute to ASP.NET Core, just to make the .NET guys happy. Given that it's such a large project, where would I start?
Ooh, that's a good question. So we do have issues marked as, I think, up for grabs or good first.
Up for grabs, yeah.
Up for grabs. So when we think there's an issue that would be a good first issue for folks to try out. Did we have a newbie label at one point? Didn't Safia?
Newbie.
What, there's like a
First issue.
Is that what it is?
Yeah.
Sorry. Good first issue, not newbie.
Yeah.
Good first issue. Then do we have that label still?
I don't know.
Okay, all right. Okay.
No,
I think so.
There are some areas that are maybe more approachable than others. If you're I don't know, it's kind of hard because it depends on what your experience is, what parts of ASP.NET Core yourself have used in your job. Like maybe MVC is a little more approachable, maybe some type of filter thing or something like that, or maybe a template change and things like that if those are up for grabs. But if you're into networking, you've done networking stuff, then maybe something much lower level. So it kind of really depends.
I think the first thing you want to do is to get context. So you want to read issues and figure out which ones you can kind of investigate. So I think as a new developer to the platform, you go to issues and you want to see, okay, customers are having this issue, and can you repro it? Can you figure out what the issue is and kind of go from there? I think like typically we try to figure out things that we think are approachable to newcomers. So combine that with trying to figure out how to reproduce the issue and actually like solve it. And then I think that's the first stage in like solving issues to begin with. Even like new devs on the team itself, like same problem, right? New engineer comes on the team, they join the team. How do you learn to work on Castro? Like it's non-trivial. So you pick something small and then you solve that one issue and then you kind of build from there, build context from there.
So Jeff says there are 38 issues marked currently as good first issue. So that might be a place to start. Yes,
yeah.
The label, yep, available. So you can filter by that.
I will say working on the framework is not like using it. It's very different. And I think there's a big shock if you're like an ASP.NET Core developer and you consume it and use it in your day job, and then you work on the framework. It's a big like jarring shift because the things we care about are things that I think you wouldn't maybe spend time on if you were doing like a website or something. But there is overlap. So if you know how to use the framework, you can potentially contribute to it as well.
Yeah, I think the sweet spot is when you identify an area of the framework that you use where you want to add features. And then you learn enough about that area that you can actually go and start contributing those features because you've gotten the context by learning how that works under the covers. That's kind of the sweet spot for most folks. All right, awesome. Jeff, do we have an online question?
We have several.
Do we have a good one?
Get a spicy one.
A spicy one? Sure, I can give you a spicy one.
Dan just like sweating.
Do you have plans to make migration from MVC5 to ASP.NET Core easier than it is now?
Okay, so the question was, do we have plans to make migration from MVC5 to ASP.NET Core easier than it is now? Dan, Mr. Migration Upgrade Assistant.
We
got an answer for this one?
are in the middle of, we've actually done quite a bit for this scenario already. We have this, the .NET Upgrade Assistant tool, which is a Visual Studio extension. I believe they're also now working on a CLI version of it. I can't remember if that's already gone out, but they're working on that too. That will allow you, it's out, yes, thank you, Mahu. That allows you to take .NET projects of quite a bit of variety, whether it's ASP.NET apps or Xamarin applications that you're trying to upgrade to Maui, and help you move them onto the latest .NET version. For ASP.NET apps, with MVC, it's a bit more straightforward, but the strategy that tool enables is an incremental migration strategy, where you actually put an ASP.NET Core app in front of your existing ASP.NET app, and then it uses our proxy, uses YARP, to then proxy any requests that aren't handled by the ASP.NET Core app to the backing ASP.NET app. And what that allows you to do is then start moving endpoints and pages bit by bit from the old ASP.NET app into the ASP.NET Core app. And the tool has some nice gestures for helping with this. Like it can help, you can like right click and say, upgrade this controller, upgrade this view, and it will run code transformations on those controllers and views and code as you move them into ASP.NET Core so that they'll compile and function. So you can use this incremental approach to do upgrades. We have docs in the ASP.NET Core doc set that walk you through this process, but yeah, that's what we would recommend. If you're coming from something that's not MVC, like maybe you're on web forms and you're trying to figure out what to do there, first thing to realize is you could just keep using web forms, like yay web forms, like it's still supported, still being shipped, and it's maintained, so you can continue to just leave your web forms apps and not migrate them. That is a perfectly valid option. But if you are looking to upgrade, you can use the same approach. It's just that the moving the endpoints over will be a little bit more manual. Like there's no automatic gesture that's going to turn your ASPX page into an MVC view.
For web forms, the controls. Yeah.
Yeah, it's work. Yeah, so you'll be doing a lot more manual rewrite, but you at least can do it piece by piece. So that's what we offer today for that.
Here's a good follow-up. If somebody's migrating from .NET Framework 4.8, do you recommend them going to 6, 7, or wait for .NET 8?
So the question was, if you are on .NET Framework 4.8 now and you were doing migration, should you go to .NET 6, .NET 7, or wait for .NET 8? There are different ways you can answer that depending on the tolerance for the various support life cycles that come with those products. In the perfect world, I would encourage you to go to .NET 8 preview so we get as much feedback as possible early, but I realize that's not realistic for a lot of people. So the reason we have a tick-tock cadence where we have an LTS release cycle and an STS release cycle is because there are different appetites for different types of support policies. So again, while I would love everyone in the world to be able to use the latest version, whether it is an STS or an LTS release, I understand and appreciate that there are many customers, about half, who want the slower cycle with the longer update window available to them, the servicing window, right, the support window. And so that really comes down to what are the practices like in your company. The fact that you're on .NET Framework 4.8 is a good start because it suggests that you're already on the latest version of .NET Framework, which puts you a step ahead of a lot of other places that are running on .NET Framework. So if you're the type of company where you feel that you can keep your app up to date with dependencies on an annual basis, where moving from .NET 7 to .NET 8 and then to .NET 9, you can do reasonably within a sub-year timeline each year, then I would encourage you to look at using the latest release, no matter what that is. So right now that would be .NET 7, and then once .NET 8 it becomes available at the end of the year, start the migration to .NET 8 as soon as possible. If that sounds like that's not something that you have the appetite for, the capacity for, then stick to the LTS train.
So having seen some of these migrations internally at Microsoft and with huge projects, I would argue going from 4.8 to any .NET version is a big jump. That is a multi-year. So you have to have a plan for going from whatever is currently LTS. It will probably go to support while you're doing migration. And we've had teams that moved to 3.1, and then by the time they got like halfway through, it was done, and then they have to go to 5 and then 6. So when you start your journey, if it's a big change to get from where you currently are to .NET 6 plus, then that first jump will be a multi-year shift. And then once you're on the new train, then going from version to version is much easier. So,
yeah, so Stack Exchange, for example, or Stack Overflow, they did a multi-year move from .NET Framework to .NET Core as it was then, and they went through that type of time window where they targeted one version initially and then the versions moved. But that's not a huge deal because you can just retarget and go to the new version when it becomes available while you're in the middle of the migration. So.
I want to answer Dan's question like you answered to the one about MVC 5. So we would say, at least with MVC, there's a place to land in the .NET 6 plus world, right? You can go from MVC to MVC Core, and like it looks similar. It has controllers and attributes and actions, and it's the same thing, right? Pretty much. Moving frameworks is hard because of the other code in your project. It's mostly not the controllers. You can migrate controller. It's the code in the controller. It's using EF6 or WCF or something that hasn't been imported. And that ends up being the long pole. Like that's what you have to move first. So we actually have this like guidebook internally for how you move from framework to core. And it's like we're putting that guidance into the upgraded assistant to make it like a tool. but it ends up being like moving shared libraries to a shared common place. And then the last piece was, how do you move without having a big bang like migration? I'm working on my current version and I want to move to core, but I don't want to upgrade and stop working on new features. That's why we did the whole like reverse proxy, right? So that we think that's the way you should go about trying to migrate piecemeal route by route to a new platform. If you do have time planned to do a migration, you could just do a big bang all at once, but that's really hard to do. Yeah, risky.
But again, it depends on your life cycle.
Tolerant.
If you have the type of software where you're doing maybe one annual release for features anyway, maybe that will work and you can move the whole thing in 1 year, then maybe that is an approach you can take.
The biggest parts of the company are trying to move to .NET Core, like some that have really big monolithic applications, and it is like multiple, like 5 years in, and maybe half of it is done.
Right.
So it's not trivial.
But these are apps that have been around a long time too.
So we're actually going through this migration process from 4.8 onwards. But a different question though. I noticed that with .NET Standard, and all my libraries are actually, we're moving the libraries to .NET Standard so we can create a pathway. But I noticed that Standard 2.1 is not supported with 4.8. What's the point of that anyways? Why have a Standard 2.1 if it's not going to be supported and it's not going to be, you know?
That's a really good question.
Look at that as a bridge.
Yeah, so.
Oops.
Yeah, oops is pretty much the answer. So .NET Standard, I think it's fair to say, represents a point in time of what we were thinking. We are not making any more versions of .NET Standard, like we've already stated that. .NET Standard 2.1 doesn't really have a place in the world even today, as you said, as you rightly point out, because it isn't really a bridge across anything of relevance anymore. And in fact, most of the time now, if you're writing your own code, for your own applications rather than publishing something to NuGet, I would always recommend first just multi-target to the distinct platforms that you need to multi-target to if you need to multi-target. And then even if you're a library author, like myself, I have some libraries on NuGet that are designed to be used with ASP.NET Core. I don't target .NET Standard. There's no benefit to me doing that. I target .NET Core App 3.1 when it was supported, and .NET 5 and .NET 6. When it comes to more shared code that isn't app plat specific, it's not WinForm specific or WPF specific or ASP.NET specific, it's just code, then there might still be an advantage, obviously, of targeting .NET Standard because you can write it once and have one assembly that will load on all platforms. But even then, you can also just target .NET 4.7 and .NET 6.0, and it'll run everywhere that's basically supported today, modulo, even Maui it'll run on, right? Because that uses the .NET 6 TFM. So .NET Standard is less important and useful than it used to be, but there are still cases where you get a benefit.
2.1 is not useful. 2.0 is useful.
2.0, that's what I'm referring to. 2.1 basically has no use. You've got shared code that you want to run in both places. That's right. Yep. Yeah, so the short answer is .NET Standard 2.1. There's really no reason you'd want to target that now. Do we have an online question?
Sure. What is Blazor United? Is that some sort of football team? Kidding. Kidding. But a good question. How can Blazor better support international and low bandwidth needs?
Oh, interesting. Well, there's stuff happening in 8 in the sense that we're doing static server-side rendering that can help the low bandwidth needs in the sense that it only renders what you tell it to render, right? It's very similar to any classic server-based rendering. And so that's helpful. What was the other one? Low bandwidth and what?
And international.
International.
Right. And so we have globalization and localization features in .NET and ASP.NET Core. So globalization, for those who, just to clarify the terms, is typically the process of making your app ready to then localize for a specific locale or culture. So you globalize first, and then you localize for wherever you want to localize it for. All that stuff works in Blazor, right?
Yeah, absolutely. Yeah, we support localization and globalization. So, I mean, I guess they would almost want to know, ask the question back, like, are
what's
there
wrong?
issues with globalization that you want us to fix? We'd love to hear about them. Like, let us know on GitHub. Yeah, the server-side rendering support in Blazor should enable Blazor usage, I think, in a whole bunch of new use cases where today it might be prohibitive either due to its download size or because of the scale characteristics of Blazor server. You get the scale characteristics of a stateless, request reply programming model, but with Blazor's component abstraction, which is really nice.
And the ability to stretch to interactivity with
When you need
WebAssembly
it,
and
that's
Blazor server if you want to, for certain parts.
Performance plus plus?
Kind of.
Web
Update
form.
panels, there's a whole bunch of things, yeah. In room, is there another in room question? Over there, okay, got one lined up.
I'm back.
I have a question about WASM. When you first start up the WASM app, it can take a long time because it have to download a lot of stuff. Any plans on making this faster, like using a CDN or something, or?
So the question was about whether we can make a Blazor WebAssembly faster to start up. And I think there's a couple pieces to that. One is the download size. And we did a lot of work on the download size already to trim things down as much as possible. We have even a tool chain that you can use that will relink the .NET WebAssembly runtime to remove features from the runtime itself if you're not leveraging them. So that's one thing you can do if you haven't already installed the WASM tools workload. That will give you even a little bit more size savings. There is a diminishing returns at some point. Like we can't trim it down to 0. Like we do need a runtime in order to make that part of the stack function. You mentioned CDNs. It was possible at one point in the past where you could put something on a CDN and have it be cached across sites, and then browsers decided that was a bad idea for privacy reasons, and so that was basically shut down. So I'm not currently aware of a way that you could download and cache the Blazor WebAssembly runtime across applications. You can, of course, do that for within an application. Like the first time the user goes to the site, they get the download. In future visits, they already have the .NET WebAssembly runtime, and they're good to go. So that's one part of it, is like how far can you shrink it down? We have a bunch of tools that you can use for shrinking it down as much as you can. I think the smallest Blazor WebAssembly app is about 1 meg total that you can get to. So that's kind of our lowest bar that you can get to.
Is that compressed, transferred, or?
That's a transfer.
That's the transfer side, okay.
Link the runtime, it removes some of the globalization features, so there are some compromises when you go that small, but that's about as small as you can go. There is also issues though with the execution of the WebAssembly runtime once it's downloaded. We have seen some reports that if you're on a low-end mobile device, you download a Blazor WebAssembly app, even if the download doesn't take that long, the execution, in some cases we've heard reports that it drags. That's an issue that we're investigating on the runtime side to see if there's anything we can do there to speed it up. I mean, there's limits to what we can do because to some extent that's the browser, like how fast can they execute WebAssembly, but that is an area that we have heard some complaints about that we are trying to see if we can improve.
You guys like fist bumping with the AOT people?
The question was, are we fist bumping with the AOT people? Yes. WASM, so there's actually 2 AOT tool chains for .NET. There's .NET Native AOT, which spun out of the Core RT effort, which we're working in ASP.NET Core 8 to support Native AOT. And then Blazor, when you're running on WebAssembly, uses the Mono runtime, and they have a AOT toolchain as well, which is used for the Maui stack and various other things as well. And there's a lot of cross-pollination and knowledge sharing that goes on. Some of the tools are actually shared between the two, and code sharing between the two. The other aspect you didn't touch on, Dan, is also obviously the time from the user's perception of a WebAssembly app. There are tricks you can play with regards to pre-rendering, and so that by the time they go to use an aspect of the application that requires the WebAssembly, wouldn't it be great if it was already there? Because maybe they have to download images and stuff anyway. Like that can be parallelized to an extent. So it's not like you're looking at a waterfall chart in a browser load with a WebAssembly app where everything is in sequence. It's like, well, I have to download the HTML, and then I download one JavaScript file, and then I download each IL separately. No, there's a lot of parallelization. And if you look at the entire user experience, like any good front-end engineer will tell you, you need to optimize for, well, okay, how long does it take till I get the first paint? And then how long until the page is interactive? And then how long until I can scroll and all those type of things? And WebAssembly has a part in there, and you can do things to kind of improve that. And the stuff we're doing in 8 will help with that as well.
There's the pre-rendering path, and there's also the auto mode, right? Where we might start you off with a Blazor server pattern on that mobile device, which loads fast because you don't have to download very much at all. But then we sneak down the Blazor WebAssembly runtime in the background so that it can be cached, and then in future visits you now have that runtime already available there. So that's an option as well. Regarding the fist bumping on the AOT tool chains, I just want to also clarify one thing, that sometimes with AOT, we talk about it makes the app start up faster. And then sometimes with AOT, that's not the case. Like when you're dealing with like a server workload, running AOT on the ASP.NET Core app can make the app start faster because you don't have to pay the cost of JITting the code to native instructions. You already did that work when you ahead of time compiled it to native instructions. In the case of Blazor WebAssembly, things are a little different. It actually it most likely will do the opposite in terms of making the app start up slower, because the ahead of time compilation will, yes, turn all your .NET code into WebAssembly, into the native instructions of the web, but that will actually typically increase the download size of the app. It will, when you download the WebAssembly instructions, you generally need more WebAssembly instructions than what were the original .NET IL instructions to represent the same functionality. So you get actually better runtime performance with AOT on WebAssembly, but typically slower load performance because the app is larger. And I know that can kind of bend your mind. Like, okay, if I'm dealing with like native client apps and server workloads, AOT makes my app start faster. If I'm dealing with Blazor WebAssembly, though, then actually can make it start slower, but it will make it run faster at execution time. So just a little detail to keep in mind there.
See, nothing is free. Like there are trade-offs all the time, and you have to keep them in mind. Yep. Online questions, Jeff. All right, is there an in-the-room question while we wait? There's one right here.
Yeah, thanks. I heard in your earlier session, Jeremy, that you talked about a new way to see endpoints with the API Explorer. And I'm currently using OpenAPI and something like Swagger UI to do the same thing and to do the try it now functionality that you also talked about. So what's the interaction between those two things, the API Explorer and OpenAPI and the infrastructure for that?
That is a great question. And that's a feature that's been implemented by our tooling team.
Yep.
And David, are you?
They do some stuff. So
David?
I think the feature is called Endpoints Explorer, and it's in Visual Studio. It's the one you're referring to. And it's a visualization of all the endpoints in your application. And so what they actually do is they spoke to us, and they said, right, so what kind of code in an ASP.NET Core application equates to an endpoint, something that would show up in a Swagger document, something that would show up in a Swagger UI. And we said, well, we have this in ASP.NET Core API called the API Explorer that you can actually ask at runtime and say, hey, can you tell me about all the APIs in this application? MVC integrates with it, Minimal APIs integrates with it. But they can't do that in Visual Studio because your app's not running, right? Like you just got a bunch of code and a bunch of files. And so what they do is they basically, you know how Roslyn and analyzers and all that type of stuff works. So they can analyze your C# code and they look for essentially code patterns. They look for cases where you have an action method, which is just a method that returns a certain type of type on a class that derives from a certain type of type in the framework. And they go, oh, that is an action because they know because it matches this pattern. And then they can find the route pattern from that because they know what that looks like. Yeah. And so they basically use a bunch of heuristics is the short answer. And then they use that to populate the Endpoints Explorer.
Yeah, so the one at tool time is an approximation. The one at runtime is accurate.
And it's a very good approximation. So the one in VS, for example, will not, if you dynamically create endpoints in your application according to runtime code. What do I mean by that? Imagine your program main or in, probably not controllers. Imagine in a program main where you can create minimal APIs. They're just delegates, right? They're just functions that you pass to another function. You can create a for loop, like 1 to 1,000, and just like create a bunch of routes that are literally have 1 to 1,000 in them or random words, and you've got 1,000 endpoints. Now, they can't tell that because they're not running your code. And then, so the Swagger doc would show that. Like you would go to the Swagger UI, you'd see 1,000 endpoints, but you won't see that in Visual Studio. So those are the kind of edge cases where they'll differ. But from what I've seen, like they do an amazing job. They do a pretty good job of all the different ways that you can set up endpoints and they find them.
I actually was talking to the team that works on the Endpoint Explorer today about this, like, you know, the design time view of the endpoints versus like getting information from the runtime, which is what the OpenAPI stuff is based on. They are thinking about, like, could they, like once the app is running, could they augment the Endpoint Explorer then with that additional information now that it's available at runtime? So you might see that happen as well. They give you as much as they know just by inspecting your code effectively, and then once the app is running, they say, oh, see, there's actually a bunch of other hidden endpoints here that I couldn't tell just by examining the code, and those would show up just like they do in the OpenAPI based tooling.
Good question that just came in. Given all the conversations about Blazor, do you see Blazor becoming the predominant ASP.NET Core UI framework for Blazor pages?
So the question was, given Blazor is awesome and just getting awesomer, do we think it will overtake Razor Pages?
I think you quoted it better.
Yeah. Okay. Yeah. So like, we all have biases. I'm a very strong Razor Pages fan person.
I wonder why.
I wonder why, because I invented it. Because I was the PM, worked very closely with the engineering team, and we came up with Razor Pages. And so and when I first joined Microsoft, I was the PM for the Razor tooling in Visual Studio. It was literally the first thing I worked on at Microsoft. So I have a long history with Razor, and I love it. But I also recognize, being a web developer before I worked at Microsoft, is that the web development landscape has in a lot of ways changed, and in a lot of ways hasn't changed at all in the 25 years or so that we've been doing web development, right? It's more like 35 years now. Oh my gosh, we're getting old. And so, yeah, stop getting old. And so I think there will always be a place for both. Well, at least in the foreseeable future. I think that's the short answer, is there is going to be a place for both. I can tell you, Blazor is growing very strongly. So Blazor as a web framework inside the community of .NET is growing very strongly. Like, you know, and so it wouldn't surprise me if we see like a parity at some point between the number of people doing Blazor apps and the number of people doing Razor Pages. But I think a lot of that's going to come down to how great a job we do at making Blazor great at all the things, right? If Blazor is just subjectively for most people better at doing what Razor Pages does today, I would expect people to use Blazor. Is it there right now? No, in my view, it's not for building the type of thing that Razor Pages is really good at today. But can it get there? Absolutely, I think it can. And so, you know, we'll see what happens. I'm sure Dan has his own biases and thoughts about it.
It will definitely be that.
There you go.
I mean, but at the same, .NET, one of the things we care about is not only innovating for the future, but also maintaining and supporting our users that are on the platform. Like, we want .NET to be a platform you can trust. We know we have tons of MVC and Razor Pages devs that are using the stack, and are they just going to evaporate once Blazor can support full stack UI development? No, and just like we still have actually a lot of web forms devs that are still being productive on the old ASP.NET web form stack, and we support them as well. So it'll be a transition. Like, it's the evolution of the web framework. Do I think that there are some really compelling reasons to have your next .NET web app be a full stack Blazor app? Yeah, like, I think there's some great reasons. The component model, the ability to add interactivity wherever you need it. I think that will end up being a really nice, productive way to build web apps.
I think the real question is, do we add new features to Razor Pages and the MVC model, given that we will have Blazor Lake? Because it's easy to say that, no, they'll all be there. They will be there. We're not going to remove stuff.
Right.
But, like, are we going to add a component model to MVC and Razor Pages?
No, we won't do that. But and it's a very good question, though. Like, I mean, the reality is, as much as I would like this not to be true, it's a zero-sum game. Like, the time that we spend working on one set of features is time that we can't spend working on something else. And the team may not be as large as you think it is. Like, the Blazor team is 4 or 5 engineers in the Blazor part, and then there's a bunch of folks under that who do mono, and there's a bunch of folks who work on the tooling, and there's a bunch of other folks. But like, the actual like Blazor features is a fairly small crew, right?
Tight and productive
crew. And now the Razor language is actually owned by the C# team, the compilers team. Yep. Now that transition happened last year. And so, you know, it's never as straightforward as saying, well, we can just equally invest in both given the number of users. There are strategic reasons why we might want to invest in one place, and then there are, you know, tactical reasons why we can't just invest in all of them at the same time. That said, there's obviously a great community. It's not just us. There's lots of people building great stuff for Razor Pages or Razor Views in MVC. You can buy control suites or, you know, tag helper suites. I have a tag helper package that I know a bunch of people use, and I add features. I get pull requests, which is great. So there's a lot of people still contributing to that stack, even if, you know, this release we're not doing as much work on that as we might be doing on Blazor. So.
There are some of the features that we're doing in .NET 8 that we have been thinking about, like, well, would it make sense actually to bring some of these features to the MVC and Razor Pages crowd? Like, one of the things we're doing in .NET 8 is like enhanced navigation and enhanced form handling, streaming rendering. These are sort of client-based progressive enhancements on what is otherwise still a server-side rendering programming model. We could potentially do those for MVC, for Razor Pages. Some of the implementation that we are leveraging for that with Blazor does, I think, utilize some of the aspects of the Blazor component model, which simplifies some of those things. But it is stuff that we think about, like, how much can we, spread? We want the investments that we make in the framework to be as broadly applicable as possible. So we do think about and consider those things as well. We'll have to see. We'll see how things go.
And a good example of that, while it's not Razor specific, is we did minimal APIs in .NET 6, introduced the new iResult return type, and then in .NET 7 we turned around and added support for that in MVC. So you can now return iResults from MVC. You can do filter interleaving between the two engines as well. So like we do look for opportunities to try and make sure that we can bridge things when possible.
Follow-up question. So then what do you think about Blazor competing with front-end frameworks like Angular? And then I have a question for David.
What do we think about it?
Follow-up question is, what do we think about Blazor competing with other front-end JavaScript frameworks? So there are a lot of great front-end JavaScript frameworks. Like, it has to be said that a lot of them have been around for a while. They're mature. They are heavily used. I wouldn't be surprised if many folks in this room are using front-end JavaScript frameworks with a .NET backend. And we know we have lots of .NET developers that are in that boat and don't plan to rewrite their entire Angular app in Blazor anytime soon.
Right.
We will continue to invest and support those scenarios as well. We have a team that's actually actively looking at the tooling experience in Visual Studio when you have both .NET and JavaScript basically within the same solution. How can we help you manage your client assets better so that you can orchestrate the JavaScript build pipeline with your .NET build pipeline? We are doing work in that space as well. How does Blazor just sort of all up, if you put them both in the octagon against each other with there are strengths on the JavaScript side and strengths, I think, on the .NET side. .NET is really strong on the server. Like, we are fast, like blazingly fast. And I think that will continue to be the case for a long time.
What are we, Dan?
Really fast.
Awesome. Thank you very much.
Yeah, we invest heavily in performance. And so your server-side rendering stack, I think that's going to be great with Blazor, just like it is with MVC and Razor Pages. On the client, obviously, we have some trade-offs when you deal with .NET running in a browser. We have to bring a runtime, and there'll be load time performance considerations there with all the mitigations that Damian mentioned as well. So yeah, it'll be trade-offs, as engineering trade-offs always are. But our goal is to provide a great front-end web UI development experience using just .NET.
So, but also just to address maybe the other undertone of that question, which I think this is an area where competition is fantastic. Like, this is not an area where I think winner takes all. There is more than enough space for more than 1, 2, 3, 5, 10 front-end frameworks, whether they're JavaScript, whether they're WebAssembly based, or whether something else appears, right? There are other frameworks that are doing transformation from one app model type to run in the browser. I won't talk about them, but you know who I'm talking about. So it's fantastic that we get this innovation in lots of different places, because it's obviously we are being inspired by what's happening in the entire front-end web community, because the industry is moving. Like, if we don't move with it, then what's the point in us having a framework that you all use that you won't be able to get that benefit from? So the competition is good, is the short answer, because we're seeing fantastic stuff come out of it.
So
we have some in-room questions as well, maybe. Okay. Go.
Hi, quick question. You guys had mentioned earlier that WebAssembly now supporting multi-threading. I wanted to see or get your thoughts on also leveraging the GPU and where Blazor can apply in GPU processing.
So we do monitor the progress on the latest WebAssembly specs. Like the WebAssembly shipped as like a minimal viable, I don't know what the piece to
product.
It's not a product, like protocol or whatever. They shipped the first WebAssembly spec and then went into the browsers, and then they've been evolving the WebAssembly platform. We are adding, we were enabling SIMD and exception handling support in .NET 8. Those are new WebAssembly specs as well. For GPU, we don't have any immediate investments in that space that I'm aware of, but we are looking at those things. Honestly, I wish we had one of the runtime folks here to talk to that. I know another spec that you might be interested in is the GC spec, like the garbage collection spec. The GC spec in WebAssembly, unfortunately, doesn't mesh very well with the way .NET GC works. Like we have very specific .NET GC semantics that we need to handle. So we will probably continue to have our own GC for a while. Yeah, on the graphics side, I think we may need to do more look there. Nothing in the short term that I'm aware of.
Does anyone have a question that's not about Blazor, just out of interest? It'd be interesting. Yeah, Phil, you got one? Yeah.
So, question to David here is, what's the status of green thread?
Oh, status of green threads.
Oh my God.
And that's going to take us to the end of this. Oh my gosh. We did a thing, right?
Good question. Good question. So I guess what are green threads? If you've used Go or Erlang, like we all do, I don't use Erlang, by the way. Green threads are a way to represent threads basically managed by the runtime instead of being managed by the OS itself. And the idea is that could we basically, let's rewind. Today, when you have async and synchronous code, they're two different worlds. All right, so we call it the function coloring problem. So async is viral, sync is viral. They can't interleave. When you call async from sync, you have to block. When you call sync from async, it's not great. So the question is, can we merge these two worlds by having a new concept in the runtime called a green thread? And now we can have one concept and, well, I guess not one, three concepts.
Add another one.
Async and no green threads.
Yeah.
So that's kind of the background. And the impetus came from seeing people port code that was legacy, that was all synchronous, and then somewhere in the call stack, you're calling something that's only asynchronous, some HTTP client call, for example, and now you have to do sync over async, and now you're running in production just fine for days, and it scales, and then bam, it goes down because of starvation, and that happened over and over and over the last, I don't know, 10 years, right? So that's finally, some of us, me specifically, went, can we do something here that's like fundamental? Can we not just add more threads to the runtime? So we spun off a crew to go figure out what would it take to make .NET implement green threads. And it was fun. We spent 3 to 6 months, and we added if you go to .NET Runtime Lab, the repository on GitHub, you can see a branch there called green threads. And it is literally adding a new runtime concept of a green thread to like .NET itself. So the method was like task.run as green thread, and you got a task back. So the idea was you start with the async top of the stack, and then every call you would make would be green thread aware. So anything that was doing synchronous I/O, so we changed the socket libraries, file I/O libraries, ASP.NET Core itself, to all be aware of, am I on a green thread? If I am, then pretend to be async. That would yield the current stack magically, save it somewhere on the heap in the runtime, and then like when it resumes, put it back onto the stack. So it was basically runtime managed threads, right? That's the whole idea. Ran a performance test. The performance was horrible because it was 3 months. But we got it. I believe it was like within like maybe 2x instead of being 20x slower. Good, right? And I think the hardest thing to wrangle was the idea that we would have 3 models, because task and async is never going away. So at the very end, we said, okay, we have a thing that we think could work, right? And the current implementation was really not great. It was more like, could we see a thing working end to end? So we ran the technical power benchmarks for plain text to see the end to end. Would we add sync APIs back to ASP.NET Core, back to everything? Do we go and say, okay, every API is now sync, async, and is aware of green threads? And I think we got stuck there. So that was there's currently no conclusion, but I think the looming thought is, do we really want to add a third model? Because it really isn't replacing the current 2 models, we're just adding a third model.
Right.
And given that, looking at Java and Go, they never really had the viral async await in their core API set, so like their core libraries. It's different for us because we actually expose task-based APIs everywhere. And the question is now, do we also go adding sync APIs that are also green thread aware? So I do think there's still, it was a very cool experiment, and we should have a write-up coming to explain like kind of what we did and how it worked. If you care about that, tell me, ping message, and I'll explain how it worked uncovers. But yeah, so I think currently it's kind of in limbo, not really going to happen for 8 or 9 because it's a huge feature, like massive, affects everything on the planet. and the performance of P invokes and some subset of what .NET does really well, like goes to crap. Like not because of the implementation, but because fundamentally it has to be bad because like
the physics
that's
of
the trade-off.
the model,
Physics.
right?
So if you're like Go and Java have this issue, right? But it's just that people don't write the same kind of code in all those platforms. So they made a trade-off. One of the cool things about Go is Go wrote most of Go in Go. So their crypto is in Go and everything's in Go. And that's good and bad. But one of the trade-offs you make when you jump to green threads is that you want to have as much code in the runtime as possible. So you don't have to kind of call into the C. Right? So that's kind of one of the big things.
And we are at time.
Woo.
That was the last question.
Awesome.
Hands out. So for those who had a question they really want to ask us, we'll stay here. You can ask us questions, but the live stream is going to end now. But thank you very much for joining us. You can always send us questions on Twitter or anywhere else, GitHub.
Everywhere.
Yeah, and we're happy to answer them. But yeah, have a great build. Cheers, everyone.
What do you want to know?